So hi students, today we will discuss about maxima and minima of a function of two independent variables. So before solving the problems, let me know about the conditions of maxima and minima of two independent variables. The first one is dou f by dou x, at the rate a comma b equal to 0, and the second one is dou f by dou y, at that point a comma b equal to 0. So after getting the partial derivative with respect to x and with respect to y, so equate with 0, so then only we will get the point of maxima and point of minima. Okay, and then main important things are, we need to find the values of L, M and N. So what is L, what is M and what is N? So clearly L is what? Dou square f by dou x square at that point a comma b. So M is what? Dou square f by dou x dou y. So first thing is we need to differentiate with respect to y and then with respect to x. Okay, coming to N, so it is dou square f by dou y square. So 2 times differentiation with respect to y. So since all these files are partial differentiation. Now coming to the conditions, the first one, very important one is, if ln minus m square greater than 0 and L greater than 0, then f is a function of two independent variables, clearly f x comma y, so two independent variables, is minimum at a comma b. So this is the first very important condition. And coming to the second one, so ln minus m square is greater than 0 and L less than 0, then f of two independent variables, the function of two independent variables, is maximum at a comma b. And what is the minimum value? F of a comma b. What is the maximum value? F of a comma b. So what we get? Then ln minus m square is less than 0. So if it is less than 0, clearly the function is neither maxima nor minima. Okay students, then finally, coming to the inequalities over, after that, if it is equal to 0, so clearly it is not defined. Okay students, so this is the conditions for maximum and minimum of a function of two independent variables. Now we will solve a problem on this maximum and minima. The first very important one is, find maximum and the minimum of f equal to x cube plus 3xy square, minus 15x square minus 15y square plus 7x. So this is the question. So what we need to find? Come to the solution. Now coming to the first one, what we need to find? Dou f by dou x, so partial derivative with respect to x for the function and equated with 0, and then partial derivative with respect to y and then equated to 0. Now coming to the dou f by dou x, so if we want to differentiate with respect to x, treat y as a constant, so that what we get finally, for x cube it is 3x square, so treat y as a constant, so 3y square times of x is what? 1 minus 15 into, for x square it is 2x, so it is 30x. For 15y square is a constant, so that it is 0, no need to take this, plus 72 times of, for x it is 1, so it is dou f by dou x. So here we have two independent variables, so that if we equate 0, so we can't get the x and y, so that we have to find dou f by dou y first and then we equate it to 0. So why? Because if you want to equate with this with 0, so we can't get x and y properly, so that first thing is we have to find dou f by dou y. See, if you want to differentiate with respect to y, then treat x as a constant, so that first one is 0, so plus 3x into y square, so for y square it is 2y 3x into 2y, it is 6xy. 15x square is 0 minus 15 into, for y square it is 2y, so 15 into y square 2y, 15 into 2 30y, plus 72x, it is 0. Why? Because the derivative is with respect to y. Now first thing is, if dou f by dou y equal to 0, what we get? 6xy minus 30y equal to 0. Now take 6y common, x minus 5 equal to 0. So 6y equal to 0, which means y equal to 0 and x equal to 5. So here we have two conditions. Now dou f by dou y equal to 0. Then coming to the dou f by dou x. So if dou f by dou x is 0, so then what we get? So 3x square plus 3y square minus 30x plus 72 equal to 0. And we need to substitute these two values, y equal to 0 and x equal to 5. So that first thing is y equal to 0. Now substitute y equal to 0 in this condition, what we'll get? Now I write this value again, so dou f by dou x, so which is 3x square plus 3y square minus 30x plus 72 equal to 0. So this is the dou f by dou x, and the values are, so I write it here, y equal to 0, x equal to 5. Now first I substitute y equal to 0 in this equation, what we get? So it is 3x square, so y equal to 0 minus 30x plus 72 equal to 0. Now take 3 common, since it is x square minus 10x plus, so 24 equal to 0. Now while solving this, x square, so minus 6x minus 4x plus 24 equal to 0, then the roots are x equal to 4, x equal to 6. After solving this quadratic equation, we get the roots are x equal to 4 and x equal to 6. Then the points are, one is x4, y0, so it is 4 comma 0, and the second one 6 comma 0. The first one is over. Now coming to the x equal to 5. So x equal to 5, so what we get? So 3 into here 5 whole square plus 3y square minus 30 into 5, so plus 72 equal to 0. So 5 square 25, 25 is 3 are, so 75 plus 3y square minus 150, so plus 72 equal to 0. So 75 plus 72, so which is 147, so 147 minus 150, so 3y square minus 3, clearly it is equal to 0. So y square equal to 1, because 3y square equal to 3, 3 gets cancelled, since y equal to plus or minus 1. For x equal to 5, we have two values for y, that is c 5 comma 1, d 5 comma minus 5. So we have 4 points have to be checked for maxima and minima. So after getting these points, so we have to find L, M and N. So clearly, so what is L? Which is dou square f by dou x square. So clearly here we have dou f by dou x, so we need to differentiate with respect to x again. So 3x square, 3 into x square, it is 2x, simply it is 6x. For 3y square it is 0. Why? Because we need to differentiate with respect to x again, so that it is 0 minus 30 into, for x it is 1, so minus 30, and the derivative for constant is 0, so no need to take this, 6x minus 30. Okay, for m, so dou square f by dou x dou y. Now so dou square f by dou x dou y can be rewritten as dou by dou x of dou f by dou y. Okay, so dou by dou x of, so dou f by dou y is what we already got. So dou f by dou y 6xy minus 30y, so 6xy minus 30y. Okay students, so if you want to differentiate with respect to x, treat y as a constant so that it is 0. Simply 6y times of, for x it is 1, so 6y over. Now n, so dou square f by, so dou y square. Then so again, so this is dou f by dou y. We need to differentiate with respect to y, so 6x is a constant, put it outside. For y it is 1 minus 30. So these are the values of L, M, N. Okay, now so check the points. Now substitute 4 points, so step by step. Now I take first point, what it is, at 4, 0. So what is L, what is M, and what is N? Now L, see here, L is what, 6x minus 30. M is what, 6y. N is what, 6x minus 30. Now coming to L, 6 into 4 minus 30. So 6 4s are 24. 24 minus 30 is what, minus 6. Now M, 6y. So it is M, 6y. So 6 into y is what, 0. 6 into 0, this is 0. Now N is what, 6 into x minus 30. 6 4s are 24 minus 30. Clearly it is what, minus 6. See, L is what, minus 6, which is less than 0. Okay, L is what, minus 6 less than 0. So we need to find the value of Ln minus m square. So clearly what is Ln minus m square? So which is equal to, L is what, minus 6, N is what, minus 6. Minus 6 into minus 6 is what, 36. Minus m square, 0. So which is clearly greater than 0. So Ln minus m square is greater than 0 and L is less than 0. Clearly. So from this condition, what we get? So L is less than 0. Ln minus m square is greater than 0. Then the function of two independent variables is maximum at a comma b. So clearly here a comma b is what, 4, 0. So ln minus m square is what, greater than 0. L is what, less than 0. Since the function is maximum at the point 4, 0. So how to find the maximum value? Substitute this into the function. So the maximum value we need to find. Okay. So maximum value of the function equal to, now substitute 4, 0 in the function. So what is the function? So here, now substitute here 4, 0. So 4 cube. So 4 cube is what? 64. 0, y is 0. So it is 0 minus 15 into 4 square, 16. So y 0. So no 0 plus 72 into 4. Okay students. Then 64. So minus 15 16s are, so 240 plus 288. Then what is our answer? 112. So this is the maximum value of the function at 4, 0. Now coming to the second one. So what is the second point? 6, 0. Now substitute at 6, 0. So we need to check at 6, 0. Now coming to the L. So L is what? 6x minus 30. M is what? 6y. N is what? Same, 6x minus 30. Okay, now substitute the points. So 6 into 6, 36 minus 30 equal to what? 6, which is greater than 0. 6y, 0, 6 into y, 0. Now again 36 minus 30, which is 6. Now what we need to find, the very important one is Ln minus m square, which is 36, greater than 0. Clearly L is greater than 0, ln minus m square is greater than 0. So L is greater than 0, ln minus m square is greater than 0, since the function is minimum at a comma b. So that the given function is minimum at 6 comma 0. Okay, then the minimum value of the function we need to find. Equal to, now substitute here 6 comma 0. So clearly, so here we need to substitute 6 comma 0. So 6 cube, okay, plus 0. So y is 0, so that here it is 0. So minus 15 into 6 square, 0, plus 72 into 6. Now 6 cube is what? 216. So okay, so minus 15 into 36, so 72 6, so 6 2 12, 7 6 42, 432. Now so 216 minus 36 15s are, so 540 plus 432. Now after solving this, what we get? 108. So this is the minimum value of the function. Okay, we have two more we need to check. So at one, what is the third one? So where it is? Yeah, 5 comma 1 and 5 comma minus 1. So at C, 5 comma 1. So clearly L is what? 6x minus 30. M is what? 6y. N is what? 6x minus 30. So 6 into 5, 30 minus 30, which is 0. 6y, it is 6. 30 minus 30 is 0. So clearly L equal to 0. Then what about so ln minus m square? So 0 minus 36, which is less than 0. Clearly, so if ln minus m square is less than 0, so what is the final answer? Ln minus m square is less than 0. It is neither maximum nor minimum. So that function has neither maximum, so nor minimum at 5 comma 1. Now then finally one last one, it is at D, which is 5 comma minus 1. Okay students, now coming to the L, substitute here 6 into 5, 6 into 5, 30 minus 30, it is 0. Now M, 6 into Y minus 1, that is minus 6 for N. So 6 into 5, 30 minus 30, which is 0. Now what about so ln minus m square is equal to, so clearly ln 0 minus 36, clearly which is less than 0. Since ln minus m square is less than 0, clearly function is so neither maximum nor minimum at D, 5 comma minus 1. Okay students, this is the solution, the process of how to find the maximum and minimum of function of two independent variables. Okay friends, thank you.